This is our health monitoring device that both measures posture score, whether the user has good or bad posture, as well as user activity, measured through how much time they have spent sitting. The device is marketable in several areas. For example, in the workplace, where many users spend long periods of time sitting and poor posture, and this device would allow them to become more aware of that, as well as prompt them to stand up periodically and get some activity. It's also useful for those who are in rehabilitation for any back injuries and want to make sure that they have the appropriate alignment in their spine to prevent injuries down the line. This device is also really important for prevention in any kind of health-conscious person. So this is how the health monitoring posture activity device works. First, the user selects the log-on button, as shown here, which prompts a dialog box that allows them to enter both their username and password. When they enter the device, they see a user profile page that describes their past data, including posture score and sitting duration. When they click New Session, they're given a preparation page that tells them how to wear the device. Here, the user already has the device on his body, and he's beginning calibration. There are 4 postures that are calibrated. Here, bad sitting, now calibrating good sitting posture, where the spine is upright. Then moving on, standing up, and doing bad standing posture and good standing posture. This is to get the entire device's full range of motion. It's entirely user-enabled. The user can do this themselves, and each calibration only takes 5 seconds. When the user is done, they select the Done with Calibration button, at which time there is live measuring. So when, as you can see, the user is in a good upright position and the posture score looks good, and it moves to bad as the user slouches. The LED shown here is off since the user is standing. When the user sits down, this LED turns on. As the user slouches, posture quality is bad, but as they stand upright, it moves on to good again. On the right shows an advanced view of this entire process, along with different session duration and time spent sitting times. This page is fully shown until the user decides to either pause or stop monitoring. Here, the user decides to pause the monitoring, at which point they can click to resume the process, and they are taken back to the measure page. The user can also recalibrate, where they can recalibrate any of the 4 postures that they had before. There's a sitting meter that also displays visually how long the user has been sitting. When they click Stop Session, they're taken to a user profile page that, again, they can view the results from the last session, and the device is complete.
One part of the code we're proud of is in this display of this posture quality gauge right here on the front panel. So what was happening when we first calculated the posture score and fed it straight into this gauge, despite the fact that the posture being calculated from the flex sensor was data we were filtering, and we had tweaked around the filter to get as good data as we can, it was still incredibly jumpy and noisy, etc. And so we wanted to smooth out the data without affecting the way we're calculating the score. And so the way we did that was just implementing a moving average. And to do that, we created a 20 element array in the beginning, right here. And then we had to update it with just the 20 most recent scores, which we're doing right here. And then for every 20, calculate the mean and display it. One exception that we had to handle was the original 20. The original 20 data points before the survey was populated, when the user first runs this. There we simply build the array until the first 20 populate, and then we just remove the first and add on to the last. One part of our project we're proud of was this user panel. This was the main place that any new user or existing user interacts with our device. And because none of the feedback on the device is on the device itself, we really wanted to flesh out a user panel. in a realization that would actually be used in a final product. And like we said, it's like a consumer-facing device where we really wanted people to see progress and encourage progress on their posture throughout every session. We wanted to see that users can track weekly or monthly progress and see that they were improving their posture. They were 50%, 60%, 70% of the time sitting in good posture. And so part of that was building this front panel. And it really was the key to importing all information and having this LabVIEW program being used from session to session, day to day, was building a user database. And the way we ended up doing that was at the start and end of every session, all of the metrics we recorded throughout were stored in a text file unique to the user's name. We made all of the paths within LabVIEW relative to the VIs, and we'd append in a logical manner the username to serve as a text file, and then read in from that file as we do right here, and update the profile accordingly. Finally, we were excited when we figured out how to determine sitting versus standing. While originally we thought this would be an extra metric on top of the posture score, we actually found that we needed to know if you were sitting or standing, because otherwise the posture, what was good and bad for sitting versus standing, was entirely different. And so originally it was an optional feature of our system, but then it became a required feature of our system. And we started thinking, all right, we'll buy an accelerometer, we'll examine the axes, fix it in a specific place for every user. But as we started playing around with that, we found that it was just way too inconsistent. No matter how accurately or consistent we would place the accelerometer on the user's back or hip, it just always changed. And so programming hard-coded thresholds for the accelerometer wasn't a viable solution. But as we continue to tinker, we end up finding that if we take the magnitude of the 3 axes of an accelerometer mounted on the hip, there was a perfectly distinguishable difference between a sitting or standing position as read by the accelerometer. And while this bit of code right here is incredibly simple, this was kind of one of our breakthroughs.